Hi, welcome to the Neurovision Lab and the beginning of the Rate and Extent of Chemical Change series. Our first session focuses just on rate of reaction and its calculation. Before we start, you'll need to be familiar with the particle model and basic reactions, which you should have covered in paper 1. By the end of this video, you'll be able to define the rate of reaction using an equation and explain how to measure it. Your keywords to remember this time are rate, reaction, reactant, product, grams per second, and centimeters cubed per second. Take a moment to write these down in your revision books. Practice spelling and sounding out the words, and listen carefully to how they're used. You can research their definitions later. So, how to calculate the rate of a reaction? The rate of a reaction is how fast reactants turn into products. Some reactions take a long time, like iron rusting, while others happen very quickly, like fireworks exploding. Depending on the experiment, we can measure the amount of reactant used up or the amount of product that is formed. These look like two separate equations, but really they're the same thing. We just swap between using reactant or product. Luckily, exams will always hint at which one they would like you to use. You just have to read the question. In this example, we have a reaction that's been running for 5 minutes. From the balance readings, the starting mass is 67 grams. Halfway through, it's 52 grams. And at 5 minutes, it's all the way down to 32 grams. It's lost just over half of its mass. If we observe what's happening, it's releasing gas, carbon dioxide in this case. The cotton wool on top stops liquid escaping, but the gas still leaves. We can't weigh gas directly, but we can calculate how much reactant was used by subtracting the final mass from the initial mass. In this case, 67 grams minus 32 equals 35 grams. Now let's organize our data. The reactant used, as established, was 35 grams. The time is 5 minutes, but we will convert that to seconds. We'll do that now just to keep things simple. 5 minutes times 60 seconds equals 300 seconds, and that's worth noting. Now we can follow FIFA, which is formula, insert values, fine-tune, and answer. This is our format for calculating extended questions. Formula: the rate of reaction equals quantity of reaction used divided by time taken. So that's the first one there. You're going to insert the values, 35 grams divided by 5 minutes. Obviously, we know. In fine-tune, we're now going to convert that to the 300 seconds that we calculated earlier. We get, in our answer, 0.116 recurring grams per second. This is accurate, but not very useful. So we can round up to two significant figures, which makes it 0.12 grams per second. Your teachers could have chosen any of these to demonstrate the rate of reaction, and you could be tested on all three. Number 1, the disappearing cross. Sodium thiosulfate plus hydrochloric acid, and it reacts to form sulfur, making the solution cloudy until the cross disappears. It takes a minute or two. The possible independent variables could be heat or concentration. The second required practical could be the loss of mass, and this is calcium carbonate chips plus hydrochloric acid with cotton wool on top. The carbon dioxide escapes, so the mass decreases over time. And the very, very common gas syringe method. Calcium carbonate chips again and acid connected to a gas syringe to measure the gas volume. This is a favourite because it's reliable and arguably quite a bit safer. It would have been with one of those large glass syringes that you'd use for almost nothing else. For both calcium carbonate experiments, the independent variables can be concentration or surface area. It's vital to learn all three. Paper 2 often includes an extended answer on one and a multi-step calculation on another. But you're here with us, so we'll go through all of them in detail in this series. At this point, your revision probably feels like a lot, but don't worry, we'll get plenty of practice. Feel free to pause the video to review or correct your notes. They should look something like this. Alright, exam time. And I've made this one quite tough. Remember, use FIFA and deliberately read the question. Highlight command words, key terms, and values. Exam designers love sneaky wording, and they will try and trick you to some extent. Question A. An experiment produces 28 centimeters cubed of carbon dioxide gas over a period of 12 minutes. Calculate its rate of reaction. Question B. A student investigates the rate of reaction between marble chips and acid. They measure the loss of mass of the flask and contents every 15 seconds using a balance. Explain how this method allows the student to measure the rate of reaction and why the mass decreases as the reaction happens. In your answer, you should refer to carbon dioxide, gas escaping, and change in mass over time. For more revision resources, tips, and helpful materials, please visit the NeuroLab store. Everything here is specifically selected or made for neurodivergent learners. And as an added bonus, each purchase supports the channel and allows us to keep producing video content. As usual, subscribe, like, and share to this channel and get your revisions sorted for GCSE. Okay, so let's take a look at this. An experiment produced 28 centimeters cubed of carbon dioxide gas over a period of 12 minutes. Calculate its rate of reaction. First of all, looking at FIFA, the formula is rate of reaction equals product divided by time taken. Insert values. Rate of reaction equals 28 centimeters cubed, as it states in the question, divided by the 12-minute time. 12 minutes is not really a suitable unit to use, so we have to convert that to seconds. So in fine tune, we do just that. 28 centimeters cubed divided by 720 seconds. Now on to answer. We should come out with 0.0388 recurring centimeters cubed per second. So we round that up to two significant figures, which is 0.039 centimeters cubed per second. And that answers our question. That should be a full 3 or 4 marks. Now, I did promise that examiners can be quite tricky with their wording, and so is true of me also. B. A student investigates the rate of reaction between marble chips and acid. They measure the loss of mass of the flask and contents every 15 seconds using a balance. Unfortunately, almost that entire statement is not super useful to us, because the question below is actually asking us, explain how this method allows the student to measure the rate of reaction and why the mass decreases as the reaction happens. This relies on your prior knowledge. In your answer, refer to carbon dioxide, gas escaping, and change in mass over time. So, the mass of the flask and contents is recorded every 15 seconds. This shows how the mass changes during the reaction. Marble chips react with acid to produce carbon dioxide gas. The carbon dioxide escapes from the flask. This causes a decrease in the mass as the reaction continues. The change in mass over time shows the rate of reaction. 6 bullet points, 6 very efficient answers. Congratulations, you've completed your revision on rates of reaction calculations. If this video helped, please like and subscribe and leave a comment. You may also want to check out our Neurodivergent Notebooks linked below. They're great for EHC plans. Use the Cornell note-taking format and include everything you need to revise GCSE science effectively. Until next time, please feel free to check out our other videos, and I'll see you here for the next in the series.